Today's lesson is 10.2 on page 404. So today it is multiplying and dividing equations with like bases. So it's a little bit different than when we add and subtract. So first of all, when you multiply or divide, you don't have to worry about them having the same exponent. So for example, this first one, I'm going to make it a little bit bigger. W to the third power times, that little dot stands for times W to the second power. You can combine them because they are both W's. When you combine these two exponents, or when you combine these two terms, all you have to do is add your exponents for multiplication. So W to the third power times W to the second power equals W to the third plus second power, which would just turn into 2 plus 3 is 5, so W to the fifth power. Even if your like terms look like a to the fourth power times a to the fourth power in parentheses like that, it's still just multiplying. You just have to add your exponents. So a does not change because you have 1 times 1 in front of them. 1 times 1 is 1, which we could just leave as a, or you can put your 1 in front of it. And then 4 plus 4 is 8. So it turns into either a to the 8th power or 1a to the 8th power. If they are right side by side, they're also multiplication. So multiplication could have the point in between them, the parentheses around them, or just have them side by side. So m times m squared times m to the fourth power. Again, the imaginary number in front of them is 1, so we're just going to leave that out. So we're going to put an m first, and 2 plus 4 is 6. So it turns into m to the 6th power. Not both of your numbers need it. Parentheses around, and this is still multiplication. This one is saying x to the fourth power times x to the first power. So if there's not anything beside them, you imagine there's a little 1 beside it. So it turns into x to 4 plus 1, which turns into x to the 5th power. So even though there wasn't a 1 right there, we imagine that there's a 1 there. And then we just add it. So 4 plus 1 is x to the 5th power. Down here, when it has y to the third power times y to the with 0 in front of it, that is just saying y to the third power times 1. So if there's a 0 right there in front of your variable, then it means 1. The entire thing is 1. So it's just y with the exponents 3 plus 0, which is y cubed. Just stays as y cubed because y to the third power times 1 would be y to the third power. If you have multiple that you have to multiply, we have g to the 0 power, which we're not even going to worry about because that's 1. So g to the 4th power stays the same, times, and now we have h to the 6th power and h to the 1st power. So it just turns to 6 plus 1, so we're going to put that h there. 6 plus 1 is 7. So we have g to the 4th power times h to the 7th power. We could also write that as g to the 4th power, h to the 7th power. We could put parentheses around it, you name it. In the case that they're like this, you just have to combine the like terms. So the like terms are going to be v to the 5th power and v to the 4th power. When we multiply those, it's just v, and then your exponent is 5 plus 4. So it turns into v and 5 plus 4 is 9. So v to the 9th power, and then we have w to the 3rd power and w to the 2nd power. So w stays the same, and 3 plus 2 is 5. So it turns into v to the 9th power times w to the 5th power, and you just leave it at that. When you divide, so all these down here are division ones. So when you divide, you're just doing the opposite of what we did when we add or multiplied. So when we multiplied, we added the exponents. When we divide, we're going to subtract the exponents. So I'm going to do a few up here. So in the case that we have w to the 4th power over w to the 3rd power, we are going to bring this w up, which means we're going to do w to the 4th power take away 3 over 1, because we moved that exponent up. So w4 take away 3 is 1, so it turns into w over 1, and that turns into w, because we could just pretend like there's no 1 right there. So number 22 would just be w. Number 23, we have g to the 12th power, g to the 5th power. Now, again, we're going to move this one up because 12 is bigger than 5, so it turns into g to the 12th power minus 5 over 1. We don't necessarily need to write that over 1, but I'm doing it just to show you what we left down there. And then it turns into g and 12 minus 5. So that would be g to the 8th power, and you could put over 1, but you don't necessarily have to. However, the reason I'm doing the over 1 is because, like number 25, we have d to the 12th power over d to the 20th. Oh, you know what? That's 7. I was totally doing that wrong. So it's g to the 7th power. I just added or subtracted wrong in my head. Okay, so d to the 12th power over d to the 20th power. Now we are going to move this d down. So when I move the g up, I put a 1 underneath it. When I move the d down, I need to put a 1 on top. So I'm moving it down to be d to the 20th minus 12th power. And the reason I did that is because 12 is smaller than 20, so your smaller number and variables have to be pulled to the bigger ones. So up here we pulled them up. Down here we're pulling them down. So it just turns into 1 over d to the 20th minus 12th power, which turns into 1. This time you have to keep the 1 over d to the 8th power. Another way you could write it is d to the negative 8th power. So if you see a negative sign, it means there's a 1 over top of the entire equation.